Hello, I'm going to talk about factorization. Let's look at an example. We have seen how to remove brackets. If I have an expression like that with a 2 outside a bracket and a plus b in the bracket, we know how to remove the brackets. We multiply the number outside the bracket by each term in the bracket. 2 times a, 2 times b, and add them. That's removing the bracket. So what is factorization? In simple words, factorization is the opposite of that. Let's say we start with 2a plus b instead, and we want to factorize this. Factorize means that we want to write it as a product of two numbers or two factors. In this case, we know that 2a plus 2b from the example just now can be written in this form. So let me write it as 2 times bracket a plus b. In this form, I have factorized them in the sense that it is a product of 2 and this bracket. The bracket a plus b is just another number. So I have a number times another number. So these are two factors. So as an example, using just numbers, I might have say something like 8 is equal to 2 times 4. Alright, just as an example. So if I write 8 as 2 times 4, I have factorized the 8. I have written it as a product of two factors. So that's what we mean by factorization. To take an expression in algebra and write it as a product of two expressions. So this time, instead of just numbers, we have expressions as the factors. So let's just look at one or two examples to get used to this idea of factorizing. Two a plus 4. We have this expression and can we factorize it? To get some idea of how we might factorize this, let's go back to the previous example, 2a plus 2b. Now you notice that in this case we can factorize it as 2 times the bracket of a plus b because we have a 2 in each of the terms. So in the first term, 2a, we have the factors 2 and a in the first term, and in the second term we have the factors 2 and b. So 2 and 2 appears in both terms. So in that sense, 2 is a common factor. Alright, we have the same factor of 2 in both the first and the second term. And that was why we could write 2 outside a bracket. And we can, in the same way, we can look for such a common factor in this example. In the first term here, we have 2a. So 2 is a factor in the first term, a is a factor in the first term. Now in the second term, we have 4. 4 can be written as 2 times 2. So in fact, 2 is also a factor of 4, right? So 4 can actually be 2 times 2. So this means that in this expression, the 2 is a common factor. 2 is a factor of the first term. 2 is also a factor of the second term. Now that we have noticed this, we can do the same thing as before. We can write the common factor outside a bracket. That common factor is 2, and we have a bracket. So what is inside the bracket now? Let's look at the terms here again. First term is 2a. We have written the factor 2 outside the bracket. So the other factor is a, and that should be inside the bracket. Right? And the second term here is 4. Now 4 is 2 times 2. So there are two factors, 2 and 2. We have written one of the factors of 2 outside the bracket, and we have one more factor of 2. So that goes into the bracket. And they should be added. So in this way, we have factorized our expression. The two factors here are 2 and a plus 2. Right, let's look at something a little bit more complicated. Well, previously, I've talked about removing brackets where we have just one bracket, and I've said that after removing the bracket, if we think about factorizing is just like the opposite of removing the bracket. So what I'm going to do now is I'm going to make a more complicated expression in brackets. I'm going to make two brackets. The bracket of a plus b and the bracket of c plus d. And I'm going to multiply these together. So in order to multiply these, I need to remove the brackets. Now, how do I remove two brackets? The simple answer is I do it one at a time. Remember that we can think of each bracket as a number. For example, the bracket of a plus b. So a and b are actually numbers. So the bracket of a plus b just means the number that you get when you do a plus b, when you add a to b. So a plus b is just a number. So think of it as a number, and you'll have a number multiplied by the bracket of c plus d. Let's work that out. If I have a number times this bracket of c plus d, let's remove the bracket of c plus d. So we can do that if we multiply the number outside the bracket. In this case, that would be the bracket a plus b, that's a number. If we multiply this by each term in the bracket for c plus d, so I need to take a plus b as a number and multiply it by the c. Number times c gives me the first term when I remove the bracket, and the next term would be the bracket a plus b times d. That's the next term after I remove the bracket, and because it's a plus there, I add them. Now if you look at this expression here, you see two terms, this one and this one. Now each of these terms contains a bracket. In this case it would be bracket of a plus b times c. I can now do the next step. I can now remove the next bracket, which is this one. So let's do this first term. I have a bracket of a plus b times c. So c is a number outside of the bracket. To remove this bracket, I need to multiply c by each term in the bracket. So c times a, ac, c times b, bc, added together. So I have removed this bracket. Now I'll remove the next bracket as well. So we go d times a, d times b, added. And between those two terms, we have to add. So if you look at this final expression, there is no more brackets. I have just removed all the brackets. Well, the two brackets. Factorization, that's what we are going to talk about now. What has this got to do with factorization? Look at this expression here, this long, complicated expression. Let me write it down here again. AC plus BC plus AD plus BD. What I want to do now is to factorize this. Can we factorize this? We know the answer already, because this expression is really the same as this expression, and this expression came from here. It came from the bracket of a plus b times the bracket of c plus d. It comes from the product of these two brackets, and if it is a product, that means that these are the factors. So this product of the two brackets, this first expression there, it is the factorization of this long thing. So the answer is simply, if I want to factorize this, the answer is simply that. A plus b, c plus d. This is the factorization of the expression. So what I've just shown you is the meaning of factorizing such an expression. But what can we do if we are given an expression like that and we don't know the answer? In this case it's easy because I started from the two factors and I removed the bracket and I got this expression. So I knew where this expression came from, I knew what are the starting factors. So I know that if I have this expression, right, that these factors are the factorization. But what if I don't? What if I'm just given an expression like that and I need to find the factors? Actually, we can try and do something that is quite similar to the steps here that has led to this expression. We can reverse the steps. Now if you look at this expression there, reversing the steps simply means going back to here. Now if you go from there to there, what you're doing is you're taking two of the terms, right? There are 1, 2, 3, 4 terms here. You would take two of the terms and you would factorize the two terms. And you would take the other two terms and factorize them separately. And having obtained those two terms, right, you then notice that a plus b and a plus b in the brackets, these are common factors. So you can then factor these out here like that and put in the brackets for the c plus d, the remaining terms there. Now, to make this clearer, I'm going to write it all out again. So starting from a c plus bc plus ab plus bd. The first step is to look for two terms that have a common factor. In this case, it is just ac and bc. We start with the first two terms and we notice that they have c as a common factor. Both the first and the second term have a factor of c. So because of this common factor, I can take the c out and form a bracket. Put the c in front of a bracket and put a and b. Inside. So this is really the same as AC plus BC if you remove the brackets. Next, we look at the next two terms, and you notice that D is a common factor. Both of these terms have D as a factor. So I can take this D outside the brackets like this. If I take out the D, I have A and B in the brackets. Like that. And I should add them. Now I have a plus sign there between those two terms. So that's a plus sign. And looking at this, you see that you can think of this as two terms. Think of a plus b here and here as a single number. So we have one term plus another term. Now in this term, the first term, we have two factors. We have c is one factor, a plus b is the other factor. So think of a plus b in the bracket as a single number. In the next term, we have d is one factor, a plus b is another factor. So if you compare these two terms, they have a same factor. They have a plus b as a factor. So since there is this common factor, we can take it out of a bracket. Alright, we can put this common factor outside the bracket and put the remaining terms, the C and the D, inside the brackets. There, we have our factors. We have A plus B is one factor, C plus D is another factor, and they are multiplied together. This means that we have just factorized this long expression. So that's how we do it in this example. Right, next, let's take a look at something which is called a quadratic expression. This is called a quadratic expression. Now, a quadratic expression is one in which we have the square of a symbol as the highest power. Now, to understand what this means, let's look at some example. X plus 1. Now x plus 1 is not a quadratic expression because it doesn't have an x squared. X cubed plus 2x squared. X cubed plus 2x squared is not a quadratic expression because x squared is not the highest power. We have a higher one, x cubed. So that's a higher power. Alright. So we are often interested in factorizing such an expression, x squared plus 3x plus 2. Now, before explaining how to go about factorizing this, which is a little bit involved, I'm just going to write down the answer and explain what it means by factorizing this. So, this is really equal to x plus 1 times x plus 2. So this is the factorization. What I've just done is that I've written this as a product of two factors. So that means that I've factorized them. Now this is the answer to the factorization of this. Let's check to see that, to convince ourselves that this factorization is correct. Let's remove the brackets. Right, now, just now we have looked at an example quite similar to that, where we had two brackets and we removed the brackets by doing it one bracket at a time. We are now going to try a faster method. Now, you'll find that if you remove the brackets one at a time, the end result is that the terms in the first bracket they are multiplied by the terms in the second bracket, and you'll find that they get multiplied together in all the possible combinations. So what does that mean? It means that the term x here gets multiplied by the x and the x there. Right, okay. I'll explain that in a moment, but let's do it the long way first. Let's take this as a number and multiply that by each term in the bracket so that we get x plus 1 times x, and then we get x plus 1 times 2. Right? And then in the next step, we remove the bracket and we get x squared plus 1 times x plus x times 2 plus 2. So that's what we get after removing the brackets, and you'll find that this is actually equal to that, which was what I set out to show, that this factorization is indeed correct. We have x squared there and there. We have x plus 2x here, which is the same as 3x, and we have a 2 there, which is the same as that. So this is the correct factorization for this original expression. Now I'm just going to show you a quicker way of doing this, removing the brackets. Right. So the way is to take a term in each bracket and multiply it by another term, a term in the next bracket. So let me start by choosing x in the first bracket and multiplying it by x. Then I'll get an x squared. Right? Then I'll multiply x by the next term, which is 2, and I get a 2x. And then I multiply the next term in the first bracket 1 by x in the other bracket to get x, and I multiply 1 by 2. Now notice that the terms here are exactly the same as the terms there. So what this suggests is that instead of removing the brackets one at a time, so removing this bracket first to get this and then remove those brackets to get that, I can simply take a term in the first bracket and multiply it by a term in the second bracket, and then I can keep doing this for all possible combinations of terms like that, and I would get the same answer. And this is a quicker way than removing all the brackets one by one. So and that's the way that we are going to use. Alright, so what I've just done is I have started with a quadratic expression, an expression with an x squared as the highest power, and I've shown that this factorization is the correct answer. Now, but what if we don't know the answer and we need to find the answer? What is the method? Now, to explain the method, let's take a look at the answer again before I clean it off. In this answer, notice the pattern in this answer. First of all, there are two brackets, and then in each bracket you have a term in x. In this case, it's just x plus number. In the other bracket, you also have x plus a number. So this is the pattern, and this is the pattern that we're going to use to help us find the answer. So now, suppose we started with this expression and we did not know the answer. I'm going to clean this off. Now we don't have the answer and we need to find it. What are we going to do? The first step is to say that the answer should have two brackets, like that. Right? And in each bracket, we have x plus a number. So that means that we need to find these two numbers. So knowing this pattern is very helpful because it means that what we need to do is to find those two numbers now. How are we going to do it? Right. Now the way to do it is to notice that if we multiply this number by this number, we should get 2. Why is that? Now if you remember from the example just now, I have said that you can remove the brackets. Instead of removing the brackets, if you want to write this factorization in this form without the brackets, you can do it by taking a term in each bracket and multiplying it by a term in the other bracket, and you can do this for all possible combinations and you would get this. For example, if you take x times x, you will get x squared. And if you take number times number, you would just get the number. But of course, if you take x times a number, you would get something like that. So, the number times the number in the bracket must give you the number in the expression, in the quadratic expression. So what this means is that this number times this number, in this case, must be equal to 2. Right, so let's think about what times what is equal to 2. Two can be 1 times 2, right? Of course, 2 can also be 4 times half. But we don't do fractions for now. We're just going to assume and hope that the answer does not involve any fractions. So let's just think about whole numbers for now. So 2 can be 1 times 2. And that's the only possible factors for 2. It's a very small number. So it means that in this case, the answer is 1 and 2. But it doesn't mean that this is definitely the answer. We still need to check that we can get the 3x, because we know that 1 times 2 gives a 2 there, and we know that x times x gives the x squared. But we need to check that when we remove the brackets, we would really get the 3x. And the way to do it is, as I've said just now, when you take x times x, you get the x squared. When you take 1 times 2, you should get the 2. But how do we get the 3x? Right, we get the 3x by taking x times the number, which can be like that, and or like that. Right? So if I have x times 2, I will get 2x. If I have 1 times x, I'll get 1x. So let me write this out. X times x gives x squared. 1 times 2 gives 2. So those are the two combinations that we've looked at. So the other combinations will be x times 2, which gives 2x, 1 times x, which gives x. So all these are added together. So x squared there corresponds to the x squared in the first expression, and the 2 there is the 2 here. So 2x plus x must give 3x, which is correct. 2x plus x is x. Now the 2x plus the x here, look at the numbers in front of the x. You have a 2 in front of this x, and x is really just 1x. Right? The 2 and the 1 comes from the numbers in the brackets, the 2 and the 1. So which means that we are really adding the numbers 2 and 1 to get the 3. So this tells us that in order for this factorization to work, when you add the numbers in the brackets, you must get the number in front of x. Let's try another example. X squared plus 5x plus 6. This involves slightly bigger numbers. Let's try and do this. So we start with the pattern. There must be 2 brackets, and each bracket must contain x and a number. So remember the method. The product of those 2 numbers must give the number in the expression. In this case, that is 6. So this number times number must be 6. And we need to find those 2 numbers. Alright? Number times number must be 6, and number plus number must be 5. So what number times what number gives 6? Let's write down the possible cases. 6 can be 1 times 6. 6 can be 2 times 3. And that is all. no other possible factors for 6. Right. So the numbers in the brackets can either be 1 and 6, or they can be 2 and 3. Which is correct? So we then think of the other feature, which is that the sum of those two, alright, numbers, number plus number, must give the number in front of x. 5. Number plus number must be 5. And we go to these factors and check which factors will add to give 5. Now 1 plus 6 is not 5. 2 plus 3, that's 5. So this means that the answers are 2 and 3, and these are added. So that's the answer. You could always try to remove the brackets and check that you get the correct expression. Right, next we'll look at the idea of a perfect square. Let's start with this expression, a plus b squared. So let's try to remove the brackets. This is really a plus b times a plus b. Now to remove the bracket, let's do it the quick way. Let's do a times a to give a squared, a times b to give ab, b times a to give ba, b times b to give b squared. So we can simplify this further. AB is the same as BA. So these are actually like terms. So this gives 2AB. So that's the answer after we removed the brackets. We say that this expression here, a squared plus 2ab plus b squared, we say that it is a perfect square in the sense that it can be written as the square of an expression. Now that might sound a little abstract, so let's think back at just numbers. If I have a number, what kind of a number is a perfect square? So for example, let's look at the number 4. We say that 4 is a perfect square because it can be written as the square of a number 2. So 2 squared is 4. And for example, 9 is a perfect square because it can be written as the square of a number as well. So in that sense, if I have an expression like that, if it can be written as the square of another expression like a plus b, then we say that this expression here is a perfect square. Now you can think of this as a useful formula. It helps if you need to factorize an expression that looks like that. Now we'll look at a similar expression that is also quite useful. A minus b squared. So if you have a minus b squared, let's look at what happens if we remove the brackets. So that's a minus b, a minus b. So we do the usual combinations. Let's do a times a is a squared. A times minus b, we have a minus sign this time. So a times minus b is minus ab. Minus b times a is minus ba. And then we have minus b times minus b. Now minus and minus cancel to give plus. So we get plus b squared. AB is the same as BA. So they are really the same term. So minus AB minus BA is really 2AB. So we have the answer. It means that this expression is also a perfect square because it is the square of A minus B. Now if you look at these two formulas, if you like, they're very similar. Instead of you have A plus B here and A minus B here. In the long expression, where you have A squared and A squared, you have 2AB, 2AB, B squared and B squared. The only difference is the sign in the middle term. Minus here and plus there. We'll look at one more similar expression which is also quite useful. A plus B times A minus B. Now let's remove the brackets and see what this looks like. Yeah. A times A is A squared. A times minus B is minus AB. B times A is BA, and B times minus B is minus B squared. We have AB here and BA here, so these are like terms. But this is minus and this is plus, so they cancel. And that means that we have just A squared minus B squared left. So let me write this down again. A plus B times A minus B. So that's the relation between these two, right? And this is not a perfect square, but this is a factorization of A squared minus B squared. So this can come in useful if you need to factorize an expression that looks like A squared minus B squared. What kind of expression would look like A squared minus B squared? So let's think of an example. Let's say we have x squared minus 4. And we need to factorize this. We can use the method that we saw just now. Just write down two brackets, the usual pattern with the x and the numbers, and try to find those by thinking about the factors of the 4. But if you happen to know this formula, we can use it. Now if you look at this and this, there is actually a similar pattern. See, you have A squared here and you have x squared there. You have b squared there, and you have 4. Now 4 does not look like something squared, but actually you can write it as something squared because 4 is a perfect square. Four is actually 2 squared. Now, if you look at these two expressions again, you can see more similarity. You have a squared and x squared, b squared and 2 squared. So what if I say that I think of the x as the a and the 2 as the b, right? If I put x into the a there and I substitute 2 into the b there, then I can actually use this formula. Just replace a by x and b by 2. Let's do that. So according to this formula, we should have a plus b in the first bracket. So I just said that we're going to take x as the a and 2 as the b. So that means I have x plus 2 here, and in the next bracket is a minus b, so that's x minus 2. So there you have the answer right away, if you know this formula. So that is a useful thing to remember. So let me write down the perfect square expression again. A plus b squared is equal to a squared plus 2ab plus b squared. Now we can also use this in factorization. If we have an expression that looks like this. So for example, let's say we have x squared plus 2x plus 1. Let's say we have this quadratic expression. Again, we can use the previous method where we write down the two brackets and try to find the numbers. But in this case, if you can notice that this expression is similar to this one, then you can actually use this formula. Are they similar? Well, let's take a look. You have x squared here, a squared there. Now you have 2x here and 2ab. If I'm going to say that a is the x, 2 is the 2, a is the x, then what is the b? If you look, compare the third term, 1 is b squared. So it could be that b is equal to 1. So let me write it in a form that looks more like that. First term is x squared plus 2x. I'm going to think of the b as 1. So let me write down times bracket 1. Right? If you multiply by 1, it's just the same number. And the 1 there can be written as 1 squared. So if I write it out this way, then they look very similar. A is just the x, a is the x, and b is just the 1. Right? B squared is 1 squared. So once you make this connection, you can use the formula where a is the x and b is the 1. Let's write that. So the a is the x and the b is the 1. And we have the answer immediately. So we'll stop here for this session. Thank you.